NASA is pushing the boundaries of human knowledge and expanding the limits of technology. I am proud to announce that our next New Frontiers mission, Dragonfly, will explore Saturn's largest moon, Titan.
This is About Space Today's special report, and I'm David Denault. Beyond the Moon to Mars.
Dragonfly will be the first drone lander with the capability to fly over 100 miles through Titan's thick atmosphere. Titan is unlike any other place in our solar system and the most comparable to early Earth. The instruments on board will help us investigate organic chemistry and search for chemical signatures of past or even present life.
If you've been following our series of Beyond the Moon to Mars, last week, About Space Today took a look at the moon orbiting Saturn, Titan. However, we didn't have enough time to talk about the mission that will launch on a SpaceX Falcon Heavy rocket in July, 2 years from now in 2028. Joining me is Planetary Scientist Dr. Ryan Ogliore of the University of Central Florida in Orlando. Well, thank you for coming back to share your expertise as a planetary scientist and what it means to you to explore Titan. Let's take a look at the science of Dragonfly, and can you break it down so that we can better understand the Dragonfly's mission?
Yes, absolutely. So Dragonfly will launch in a couple years. It is either a quadcopter or an octocopter, depend on how you think of it. It's like, the drone helicopters we see where it's got 4 rotors, but each arm has 2 rotors for redundancy. So this is a really cool mission. So Titan has low gravity and a very thick atmosphere, so about 50% thicker than Earth. And the combination of those two things makes it very easy to fly on Titan. And so you think of space and you don't think of, flight, but that works very well on Titan. So Dragonfly will come in and land on a very cool dunes of Titan near a famous impact crater on the surface. And then it will fly around. It can fly up to a mile. It'll hop around and go to different locations on the surface of Titan. And it'll have a suite of instruments on that helicopter. And its primary purpose is to understand the kind of chemical composition, the organic chemistry of Titan's surface and subsurface. So it'll be equipped with a drill. It could drill down below the surface of Titan where it lands and explore the chemistry, the organic chemistry of that material right under the surface. So we'll look at the interactions of water and nitrogen, that kind of thing. So it's very cool, very exciting mission. I say we because I'm part of the NASA community. I'm not working on this in particular, but I'll be a huge fan of this. I'm working on another mission that would explore a moon of Jupiter a bit closer called Io. But this is another end member of that fascinating fabric of moons in the outer solar system. This one, Titan, is very cool, and we'll see what can happen in this planetary laboratory of carbon, possibly prebiotic chemistry that's happening on Titan's atmosphere and surface, and these lakes and rivers of methane. So we have an Earth-like environment where all of these chemical processes are happening and mixing with each other. It'll be a very, very exciting mission.
We're not going to send men to out that far unless we have some way of speeding up and getting there.
Yeah, 7 years is a long time. So we can go straight there, and maybe you can get straight there in a few years. I hope, and we are now investing in nuclear propulsion technology. So this is using nuclear fission, so something we do all the time here on Earth, to create rockets, either thermal propulsion or electric propulsion, where we're using an ion engine, essentially. So to do all this exploration, whether this is robotic exploration that I'm super interested in, particular, or human spaceflight as well, we need new propulsion technologies. And it's a very exciting time because we're investing in those now, and it's been a while. A fission reactor in space sounds like sci-fi, but it will get us to all these places in more human timescales. And I think it's finally happening.
So we're going to launch this on a Falcon Heavy rocket in July, 2 years from now. So we're going to have to wait how long? 7 years before it gets there?
That's right. Yeah, it's the outer solar system's tough. It might be 6.5 or something like that, but it'll yeah launch on a Falcon Heavy. The one that had with the boosters that
Yes.
land. I think it's recoverable, so it'll bring those two boosters back. But then it's 6.5 years out there, and I would love to go straight there. Be there in 3 or 4 years with the nuclear rockets, and maybe someday we will. And this is like kind of my son's kind of his generation. They'll get there to these outer planets in just a few years. That would be awesome. And back. So the thing that I'm super interested in is going to these planets and bringing stuff back. So then that doubles the time, or even worse. And so we really need these new propulsion technologies, these nuclear rockets, to be able to go to Titan and bring back some of those prebiotic compounds to study in the lab.
Thank you for joining us in our series and extending one more week and learning more about Dragonfly and a great mission ahead for NASA. Thank you for your participation.
Great. Thank you.
Dr. Ryan Ogliore, Planetary Scientist of the University of Central Florida. Continue to check out our Facebook page at aboutspace.today for launches, landings, and special reports. And if you like our reports, click like, follow, and hit that subscribe button. And to all our listeners around the globe and here in the U.S., thank you for taking time from your home or where you work to listen today. I'm David Denault.